Hi everyone, I'm Takeshi. I am a developer relations engineer for Android developer tools.
And hello everyone, I'm Paris. I'm a product manager also on the Android developer experience team. Today, along with Takeshi, we'll walk you through the state-of-the-art of compose tooling in Android Studio. Through a typical UI development workflow of design, develop, and debug. We'll share our favorite compose tools in these 3 different stages. Specifically, in the design stage, you'll learn how to leverage Compose Preview and its sub-features to create components, design systems, and screens to align your design specs. In the develop stage, you'll learn how to accelerate building and testing your running applications with Live Edit and Compose Editor features. And finally, in the debug stage, you'll learn how to analyze layouts and recompositions to improve UI performance with Layout Inspector and Profiler. So let's get started. First, starting with the design stage, let's build some UI with Compose Preview. But before we do, just a quick refresher, Compose Preview is a tool where you can annotate any of your composable functions with the preview annotation and see a visual rendering of your composables on their preview panel. Essentially, it is a way for you to iterate on your UI without running the app, see different states, navigate to go, and other features that we'll go deeper into. So let's get started. We'll be using examples from the Now in Android app. Let's say you're trying to build a For You screen here, and starting with a very, very simple component, the button. The button, this is the button specification. There's some color definition as well as some padding. So what I've done here is I've already created a NIA fill button composables. I usually add a preview composables so I can see my preview side by side as my code changes. Let's update the style colors as well as add different paddings so that the button is more to spec. You can see that the preview now is faster and it's updating as I make my code changes. This is a result of our continued investment into stability, and it's available in the latest version of Android Studio. We've also updated, you may notice, the status indication to the top right corner of the preview. You can see all different statuses of the preview on this top right corner. This tells you whether or not the previews are up to date compared to the code in this current file. Now let's say the designer actually wanted a color change anytime this button was clicked. So here I've just defined a very simple generic click event that changes the button colors in the code. I can then use the interactive preview to test it out. So if I enter the interactive preview mode, you can see I just click on the button and the color changed. The interactive preview is useful as a sandbox environment to quickly test different states as well as gestures such as this one. It also plays animation. It does have some limitations. It's not running the actual device, but it is meant to aid in your design workflow quickly. Speaking of animations, Jetpack Compose's animation API are great to make designers' motion spec come to life. If you have animations built using Compose, the preview will detect and show the third animation icon. So I can enter the animation preview to scrub through the animation. I can also control different speed, in this case, slow it down to pinpoint what's going on. I can even freeze individual transitions so that I can coordinate to make sure they coordinate together. Look at the graphs to compare it with design spec. Currently, the animation preview supports update transitions and animated visibility, and we plan to add more. All right, now that the button is to spec, I can start using the preview parameters to ensure it works correctly across different conditions. For example, I have localized my button here into different languages. So I want to create different preview by repeating the preview annotation into different language. So I can have preview for a Japanese button, Hungarian, Arabic. You can actually find a full list of the parameters in the preview documentation, but some common ones you can think about are themes, font sizes, and devices. Let's say my app target these languages, so I want to be able to reuse these 4 previews quickly. To do this, I can use the multi-preview annotations, which is a way to define an annotation class that itself has multiple preview annotations with different configurations. Adding this notation to a composable function will automatically render all the preview at once. So let's see this in action. I have grouped these 4 different language previews into something called locales preview annotation. And all I have to do is to use this locales preview annotation to apply to the button that I just made, and you will get the 4 language previews directly. You can even use multiple multi-previews together. So here I've defined at the top a themes preview that has a light and dark theme, and at the bottom I have 4 different font scales into a font scales preview class. If I apply these 3 different themes, font scale preview, as well as locales preview into the different buttons that I make in this app, you can see that I now have multiple states of my buttons. So many buttons. This actually leads to my next use case of composed preview, which is building a full design system. On the screen here is a sticker sheet of the non-Android design system. You have your color themes, typography, and of course, all the buttons and components. What I love to do is actually recreate my own sticker sheet using composed preview. On the left, you can see this is my themes preview, also my typography. On the right, you can see a catalog of all the components that is available in this app. This is not only useful to compare with design spec, but also for any newcomers to the team, they can quickly ramp up to just taking a look about what components is available in the app to build new screens. If and when my designer decided to make any changes to the themes, in this case, changing this purple base to a green base palette, I can make the same changes in the same file and just compare the spec side by side. I can also check to see if the new themes have affected the components correctly, the styles are inheriting correctly. Now that I have my components, sticker sheets, I will continue to use the preview to build bigger components, such as this card, as well as full screens. When you're building bigger and more complex components, like the card here, you may need to start supplying data to your preview so it resembles your data type. In this case, this chart takes in a news resource type that has a header image, authors, URL, content, and more. One neat trick here is I can create a resource data card provider class that implements a preview parameter provider class and returns the sample data as a sequence. This is a list of news resource sample data that I just put in with different styles. You can think about things like no authors or longer paragraphs. And then all I have to do is to pass that sample data to a composable preview function by adding a parameter with a preview parameter annotation of this resource data provider, which then will populate the cards in the sequence of the sample data I provided. Ooh, okay. All right, finally, when building full screens, I can also leverage the device spec parameter in preview to put screens into different screen sizes. I can make custom device sizes, but autocomplete will actually give me the recommended reference device list. If we leverage what we just learned about multi-preview annotation, we can put all those preview devices into a device preview class. And if I apply that to the For You screen, I can see that my UI changed across different screen sizes easily. To recap, in the design stage, composed preview is my favorite tool to iterate the UI without running the app and make use of the various features such as interactive preview to test gestures, multi-preview to build components, sticker sheets, preview parameters for sample data, and animation preview for fine-tuning animations. There are more extended functionalities of the preview that I couldn't go over today, but make sure to check out this short link for more. Now I'm going to hand it over to Takeshi here to walk you through his favorite tools in the develop and debug stages of building Jetpack Compose UI.
Thanks, Paris. Now let's talk about the compose tooling during the development phase. After the design is fixed, you are going to develop a feature and see how the app experience is like on the device. Lightweight is a tool to help you iterate the development cycle quickly. without waiting for the entire app to be built and deployed to the device. The typical development workflow will look like this diagram. At first, you want to edit the code, run the app, wait for the app to be built and installed. And then finally see how the code change affects the UI. Then you go back to editing again. Live edit makes this cycle faster, as now you don't have to run the app and wait for the entire app to be built and deploy to the device on every edit. Let's see how live edit works using now in Android. Here, I have an emulator in Android Studio. I'm going to add social links to the author screen. First, I'm going to add an icon for Twitter and load the drawable from the resource and adjust the size by using a modifier. Then I do the same thing for the icon for Medium. Actually, I want these icons aligned horizontally, so I will surround with row. The layout looks now good, but clicking the icon does nothing at the moment. So I will add a click handler that sends an intent to the author's profile page. Okay, once I'm done, then click the icon again. This time it has brought us to the author's profile page. As you see, all of them happened without restarting the app. You may be wondering what is the difference between Compose Preview and Live Edit, because they are similar at first glance. You can use Compose Preview when you work on the individual composable, or when you want to see a composable under different configurations, such as device themes, device sizes, and font sizes. On the other hand, Live Edit lets you see the entire app experience on the device, which allows you to load real data. Since the introduction of Live Edit, we've added new features. The first point is that Live Edit no longer needs to reset the composition after code changes. As you can see, making an edit to the interest screen with Live Edit used to navigate, taking us back to the first screen of the app. From electric view, Live Edit doesn't reset the composition, so you don't have to navigate back to the interest screen after the edit, which makes the experience less interruptive. The second point is when Live Edit refreshes the device. A feedback we received repeatedly was the developer wanted to have more control over when the code changes are applied to the running device, depending on the current task or preference. Auto refresh, which means the code change is pushed to the device on every keystroke, has been the default mode since Live Edit was announced. But there were some situations where you don't, where auto refresh wasn't the best option. For example, when you don't want to re-execute the code over and over as you type. Starting from Flamingo, you will have the option to trigger the code change manually to the device. With manual mode, refresh mode selected, once you start editing, the status is changed to needs refresh. After editing the code, change is deployed to the device when you explicitly type the combination of keys, giving you more control over Live Edit. The last one is about the error handling. Previously, Live Edit would pause when there was an unexpected error, but it didn't tell you what part of the code caused the error. Starting from Flamingo, Live Edit shows you the path. Starting from Flamingo, live edit shows the path to the stack trace, allowing you to navigate to where the code error happened. The screen capture is the sneak peek of the feature. The experience will be improved while incorporating your feedback in the canary channel. Note that in some situations, you still need to rerun the app, even if you are using live edit. For example, when you run the app for the first time, when you add or delete a method. At the moment, live edit is an opt-in feature. You can enable it by going to Settings, Editor, then Live Edit. In Android Studio Flamingo, Live Edit will be enabled by default in manual mode, where the developer needs to trigger an update. Next, let's talk about the editor features. As you are getting used to compose development, these will allow you to boost your productivity. They are divided into 3 categories: intention actions, code completion, and live templates. You don't have to remember all of them because there are a lot of features. But let me introduce some of my favorites. The create a composable function intention allows you to create a composable function based on the selection in the editor. The intention will create a composable function signature with the argument inferred from the selected code. Another useful intention is to surround composables with a container. That means any of the box, row, or column. This allows you to avoid adjusting the matching parentheses at the end of the container. When creating a modifier parameter, you don't have to, you can start typing the name of the modifier without typing modifier first. Using this auto completion will also add any imports that are needed. Here, some frequently used live templates. You can type COMP to create a new composable. Similarly, you can type PREB to create a preview function. It's much quicker than typing them manually. Let's recap what I have talked in the development phase. I explained the live edit makes the development cycle faster, and the manual mode that is added in Flamingo. Check out the linked URL for more details. I also talked about the editor features. They are divided into 3 categories. I explained some of them, but we are working on more to come in addition to those. Moving on from development to debugging. As you gain users, some users might start reporting issues such as junk on the UI. There was an actual issue in JetSnack that scrolling the title bar caused a junky animation, especially on low-end devices. Note that the issue is now fixed, and I will just take it as a case study. This is often caused by too many recompositions. Let's go over what is the recomposition and how it matters on app performance. Remember that compose has 3 phases. The composition phase determines what to draw by building the tree of composables. The layout phase takes that tree and determines where to draw by calculating them. The draw phase actually renders the composables to the screen. Recomposition is the process of calling your composable again when inputs change, which triggers that composable to go through the phases again. If no inputs are changed, the compose can skip the entire phase, which leads to performance gains. That's the reason you need to care about the recomposition counts. Android Studio offers a tool that allows you to see the number of recompositions in layout inspector. The numbers on the left are the recomposition counts, and the number on the right are the skips counts. If you look at the jet snack before the issue was fixed, you can see the increasing number of recompositions on every frame or so, which looks problematic. Note that starting from Android Studio Electric Wheel, the UI component that recomposed is highlighted in red. Now we have identified that too many recompositions are happening. Starting from Android Studio Flamingo, you can use compose composition tracing, which allows you to see the composition tracing in the profiler. Before it was introduced, the profiler only showed the block per frame, but it didn't tell you which composable triggered the recomposition. With compose composition tracing enabled, it helps you to investigate what composable function caused the recomposition. In JetSnack's case, as I have a closer look at the tracing, it turns out that the function in the title composable may be suspicious. Let's recap what I have talked in the debug phase. We covered what is recomposition and how it matters on performance. And the recomposition counts in layout inspector helps you investigate what part of the UI causes a lot of recompositions. Then starting in Flamingo, you can use compose composition tracing to investigate what the composable function is suspicious. Now we have identified what the composable caused in number of recompositions. There are several ways to improve the code. Check out the ADS talk about the dedicated Jetpack compose performance, or the Medium post about how to improve the problematic code. Let's recap the tools in each workflow. In the design phase, compose preview and interactive preview let you validate your UIs. And the multi-preview allows you to evaluate the composable under different configurations. Preview parameter supply sample data to populate more authentic previews. And animation preview lets you investigate animations. In the develop phase, live editor accelerates your development cycle. Editor feature boosts your productivity. In the debug phase, recomposition count in the layout inspector helps you investigate, find the unnecessary recompositions. And the compose composition tracing allows you to spot the suspicious function that triggers too many recompositions. We know that the UI development is iterative and often happens in parallel. So you can use those tools interchangeably in the three workflows. After this talk, now you are ready to leverage these tools to build a beautiful, performant, and adaptive Compose UI. Check out the Compose tooling doc to learn more. Thank you.